Hi, this is Christy McGraw, and the project that I did was over the solar ovens. And the Solar Oven Challenge is a technology um, enhanced project-based learning activity that was designed to teach students about energy in sixth grade science. Over a period of about 2 to 3 weeks, several different energy topics are introduced, including energy resources as well as thermodynamics, and then eventually they use that information to create solar ovens. Energy resources, is a reoccurring TEK. It starts in about first grade and goes all the way through eighth grade, and so it's really important to engage the students on that topic and make sure that they're receiving new information. Thermodynamics is fairly new. They get a little bit of that in fifth grade when they talk about the conduction of metals for electricity, but they really don't talk about heat conduction or radiation or convection. Um, and it can be a little bit of an abstract concept, so it's nice to use technology to help with that. Um, Technology is used throughout the entire unit, and it definitely helped to engage the students and also to enhance their learning. So not just teaching them grade level TEKs, but also being able to extend further for students who are ready to go further. They also were able to have the opportunity to research collaboratively and to use the technology to document their findings. The first part of this was that students researched energy resources. So they were assigned an energy resource, and they had to they had to complete research on it to prepare for a debate. So after students had completed their research, I had them work on or put their information into a Google Doc to share that information with the whole class. So basically, they just listed advantages and disadvantages of their particular energy source. So the solar group put advantages and disadvantages for theirs, and so on and so forth. This probably wasn't the best way to do this because the students were good about putting their own information in, but they weren't very good about going back and reading other people's information. I think if I had it over to do again, I would probably create something like this, a Flipgrid. I went ahead and put one together. We haven't used it, but I think that this would be a better way for students to present the information that they found. Maybe a bit more engaging and a bit more interactive. The students might enjoy watching their friends' videos more. So this is probably what I do differently next time, is I would use a Flipgrid instead of a Google Doc. Still allow them to share the information that they want to, but I think it would do it in a more engaging way. So after students finished their research, then the next part of this was to complete a debate. And this started off with kind of more of a game format. Kids are not really familiar with debate yet in sixth grade, so we start with more of a game. And so I put together a PowerPoint to kind of go over the expectations for that. And that PowerPoint just says it's the Great Debate. And the object of the game is to reach to be the first team to reach the top of the game board. And the game, of course, is played in rounds. How to play is that each table was assigned the energy resource, and they can move up by giving an advantage of their own energy source, or they can move down by giving a disadvantage of they can choose to move someone else down by giving a disadvantage of that person's energy source. And then the debate part comes in with if a team gives an advantage for its own energy source, then they can move up one space. If an opposing team does not agree that that statement was in fact an advantage, they can raise their hand to object. The opposing team has to convince the teacher that the statement is not really an advantage. And then the team that stated it was an advantage still has the opportunity to defend their position. Ultimately, the teacher decides who won the argument. Points, again, if a team was correct about their statement being advantage, then they move up. If an opposing team disputed that somebody's was, and it was in fact an advantage, then not only does that team still get to move up, but they have to move down because they said that something was an advantage that was. I added on a couple more rules here, that if they shout out or speak before their team is called on, or they're talking during another team's turn that they're going to move down, really just for classroom management purposes. So after going over the game rules, the next part of this is to go over what the game board actually looks like and to give them actual statements to use in their debate. So this is where need.org, that website comes in very handy. They have a lot of information on there. It's all free as well. The energy info booklet, it gives you let's see, the standards, correlations, and all of that, and then it talks about what is energy, and it also gives you these 2 pages on each energy source. So I allowed the students to do their own research, but I provided each group with their information as well. So for biomass, they received this information about biomass as well as whatever they could come up with and find on the internet, just so that they weren't searching for sources. Each group, of course, got theirs when they were doing their research. And then as we go further down, let's see, it gets into climate, and talk more about hydrogen. You can get into a lot more details if you're wanting to. So this is the other source that I use that's super helpful. It is the Great Energy Debate paperwork. Basically, it's like a lesson plan for teachers. As you go through this, it goes over the details of how to complete the debate. And it gives them these sheets that list statements for each energy source. And then they have to mark if that statement is a fact, an advantage, or a disadvantage. This is what the energy debate game board actually looks like. And so teams all start here in the middle, and they can either move up or they can move down with disadvantages. Again, each of them get this packet that lists advantages and disadvantages. I'm going to stop the video for just a second here and pass out some papers so you guys can kind of see this a little bit more firsthand. Okay, so you should all have this now, but it's the energy game board as well as these papers where they mark, is it an advantage, is it a disadvantage, or is it just a simple fact? So they use these statements. If they list or if they give an advantage for their own resource, they move up. If it's not really an advantage, somebody else can question that, and then if they're correct, then the other team moves up, and they don't actually get to move up. The other thing that you can do is choose to move the other team down by giving a disadvantage. So if one of the other, let's say natural gas, gets close up here to the top, then petroleum can, instead of moving themselves up with an advantage, can choose to move natural gas down with a disadvantage. So the game kind of just goes on. And honestly, I've never had any clear-cut winners. As the student groups move up, then somebody else comes in and moves them back down. And the whole point of this is, at the end of it, we have this discussion where we talk about how all of the different energy sources have advantages. They all have disadvantages. There's not really one clear-cut winner. So that's basically the concept that we want them to take away from this game. So the second part of this is the hands-on lesson on conduction, convection, and radiation. And this is one I've done before. It's an activity from STEMscopes, and it's good because it's hands-on. The only thing that I really did was add a technology piece at the end of this. I'm going to show you the teacher setup video. I think that'll help explain the lab activity a little bit better, and then I'll talk to you about the technology piece.
Part 1. Temperature and thermal energy transfer. Distribute one very small chip of ice to each student. The student should place the ice chip in the palm of their hand. As the ice melts, facilitate a discussion regarding the direction of thermal energy transfer. Students will now answer the questions in Part 1 of the Student Journal. Part 2. Conduction. Students will use the ruler to place their cans so they are spaced about 15 centimeters apart. They will place the aluminum foil bridge over the top of the cans and use the masking tape to fasten the foil to the inside top of the can. Students should place the small wax balls at 3 centimeters, 8 centimeters, and 13 centimeters across the foil. Students will light the candle with a match, slide it under the first ball located at 3 centimeters, and then start the timer. Students will record the time it takes for each ball to melt. Once all data has been recorded in their student journal, students will complete Part 2 questions. Part 3, Convection. Students will begin this part of the activity by observing the lava lamp and picking out one of the blobs near the bottom and watching it travel in the lamp. To demonstrate thermal energy, light a can of cooking fuel and place it in the light of a projector. The students will observe the shadow of the heated air rising from the can of cooking fuel. To stop the flames, carefully place the cover for the can back on top. Students will now complete the Part 3 questions in their student journal. Part 4, Radiation. Students will clamp the lamp in place and position the light source so that it is level with the radiometer. They will place the radiometer so the bulb is 20 centimeters away and then use the thermometer to record the temperature near the radiometer. Students will turn on the lamp and use the stopwatch to time for 3 minutes. They will record whether or not the vanes move and describe the motion. They will also record the temperature near the radiometer after the 3 minutes. Students will record all data in the boxes provided in the student journal. Students will repeat this process for a measurement of 15 and 10 centimeters away. Once all of the data from the 3 measurements has been recorded, students will answer the Part 4 questions in the student journal. Students will wrap up this activity by completing the reflections and conclusions.
Okay, so you just saw the video of the hands-on lab investigation that the students complete for conduction, convection, and radiation. The second part of this was I had the students create a shadow puppet at their table, so just with their regular table group, explaining conduction, convection, and radiation. And it was actually a really good way to get kind of that informal feedback to see who understood what and what we still needed to maybe go back over again before we started our solar ovens. So the third and final piece to this was the solar oven cook-off. And this is the part that the kids were excited about, and it took a lot longer than I anticipated it taking. I originally allowed 5 days for it, and I think we went almost 2 weeks out. But the kids, basically what they did was they researched different types of solar ovens, and then they came up with a design plan, and they drew out their design. They acquired their materials. They had to use all recycled materials. They weren't allowed to go purchase anything. They built their solar ovens. We took them out and we tested them to see if they would pasteurize water, to see how hot they would get. And then we had several that failed, and so they brought them back in and they redid some research and redesigned and rebuilt. And then we had the solar oven cook-off. The last part that we haven't gotten to yet is finishing up their iMovie videos, because I did want them to include an explanation of how their solar ovens worked. So they're still working on that piece. But it was a lot of fun. The kids really enjoyed it. And the technology piece that I had them do on this was they had to include like in their iMovie, they had to include pieces from the design, so pictures, video clips, that sort of thing, from the construction, from the testing with the pasteurizing water, from the rebuild and and then going back out and actually doing the solar oven. And then the final piece of that is for them to give some information about the how the solar oven actually worked. And so like I said, they're still finalizing those videos, but based on what I've seen so far, the videos are going to be really cute. So I'm excited about that. That was pretty much my project. I did have some literature resources that I'm going to share with you in just a second. But that kind of goes over everything that we learned.